Good morning. I'm Bill Carney, the Director of Media Relations here at the National Academies of Sciences, Engineering, and Medicine. Welcome to this morning's briefing. The briefing will last 1 hour or until there are no further questions. Following the opening presentation, we will be taking questions, and please use one of the standing microphones here in the room, and please identify yourself and your organization. I'd also like to welcome all of you who are watching us live on the web. You may also submit questions via email on the web, and I also encourage you to follow the conversation on Twitter at #ExtremeWeather. I'd like to begin by introducing Dr. Ralph Cicerone, the President of the National Academy of Sciences.
Thank you, Bill. Good morning, panel. Welcome to the historic National Academy of Sciences building for the release of this new report from the National Academies of Sciences, Engineering, and Medicine. As you know, it's about extreme weather events. We've known for a long time that extreme events, especially with weather, have posed a risk to human property and societies and individuals. In recent years, though, the cost of these extreme events has been increasing fairly steadily. There are data from insurance companies and reinsurance companies that have been released over the last few years that make that clear, along with others. We've also seen individual examples. For example, the ongoing drought in California, which might fall into this category, heat waves in Russia, Superstorm Sandy, and the floods in South Carolina last fall. And in this era of human-induced climate change, after such an event, a question often arises about whether climate change itself is exacerbating these events. And usually when this question comes up, the answer from scientists tends to be something along the lines that, well, what we do know is that climate change is increasing the frequency or intensity of some types of extreme events. And in fact, previous reports here from the academies reviewing literature have looked at the long-term trends and have concluded that heat waves are becoming more severe and that extreme rainfall events are increasing because of climate change pretty much around the world. But scientists usually also have been very quick to add that it is impossible to say to what degree a particular individual extreme weather event was caused by climate change. That also is now beginning to change, however. There's, as you will see, a fairly new area of science is looking to provide better answers to the questions like the ones that I just exemplified, like how climate change might be affecting these specific events. The report being released here today summarizes the state of this science, which is being called Extreme Event Attribution. As you will soon hear from the committee members who we're fortunate to have here today, who contributed to authoring the report discusses how it is now possible to estimate the influence of climate change on some types of extreme events, as well as how to present and interpret results from extreme event attribution studies themselves. Of course, the report also describes some of the necessary research that's going to have to be conducted to continue to improve these capabilities. I should say again that this type of science is very new and is advancing rapidly. The approaches involve statistics, climate modeling, numerical modeling, and large data sets. And the results can sometimes be complicated to interpret and to explain. Scientists are still in an experimental phase during which different groups are proposing new approaches, which in turn are being examined and critiqued through the peer review process and research journals, of course. As such, this new report is pretty timely in that it can help provide some common language and a framework for the science to continue to progress rapidly. I do want to introduce members of the committee who are here today who can present the report and who will, starting with the committee chair, Professor David Titley. Titley is professor in the practice of meteorology and also founding director of the Center for Solutions to Weather and Climate Risk at Penn State University. He's also a senior adjunct fellow at the Center for New American Security. He retired from the United States Navy not long ago, the United States Navy, with the rank of Rear Admiral. Joining him are Dr. Marshall Shepard, professor and director of Atmospheric Sciences program at the University of Georgia. Dr. Shepard is also a past president of the American Meteorological Society and a host of the Weather Channel's talk show, Weather Geeks, which I've become a fan of. I never thought I would, but I'm a fan of it. I used to make fun of weather geeks. They've become much more cuddly and useful, I think. Our second Dr. Shepard is Dr. Theodore Shepard, the Grantham Professor of Climate Science at the University of Reading, a leading center of atmospheric science in the UK and in the world. We're very pleased also to have Dr. John Walsh, the President's Professor of Global Climate Change in the International Arctic Research Center at the University of Alaska. We all have to thank the committee for their dedication, and the names of the other committee members who are not here today are listed on this report in brief summary document that some of you have picked up. We should thank all of them, quite expert group. They did this job in just about 6 months. I'd also like to thank the report study director, Katie Thomas, and the rest of the staff of our Board on Atmospheric Sciences and Climate for facilitating so much of this project. I'd like to turn it over now to Admiral Professor Dave Titley.
Thanks very much.
Good morning. Good morning.
Thanks so much.
Thank you.
Great. Okay. So what we're going to do, good morning, everybody, and good morning to everybody who is on the web getting this virtually here. If you don't mind, I'm going to play with my phone for 2 seconds, and the reason for that is not to go play with Twitter anymore, but to set up a timer, because I really want to make sure that we have a lot of time for questions. And if you let me talk, well, that doesn't always happen. So we're just going to set this up, and we will be, I think, good. Let's see, there, and yes. Okay. All right, so we'll go through, I'm going to give myself about 25 minutes, and you can see how well I do. And that will give us, again, a lot of time for questions, because I'm sure that's really, frankly, the most interesting part of all of this. So, Dr. Cicerone, thanks so much, sir, for that very kind introduction. And this has been a very interesting committee, and as Dr. Cicerone mentioned there, we were able to complete this task in about 6 months. So thanks especially to Dr. Katie Thomas and really the entire National Academy staff for helping us make that happen. It was not only, I think it's an interesting report, it was done in a timely fashion. So what we'll do right now is just walk through. Okay, this worked in practice. Okay, could somebody get me the next slide, please? Thanks. Okay, so just to set the stage, we're not going to spend much time on this at all, but I hope that everybody listening here understands that the climate is changing, and a large part of that is due to human-caused influences. There is overwhelming and independent multiple lines of scientific evidence to support that assertion. The national academies have been involved for decades in these, and America's Climate Choices, amongst others, you can see on the right there. So I'm not going to spend any more time on that, but remember, that is the baseline, and that's not what our committee was asked to look at, was whether the climate was changing. Our charge was to look at specific extreme events. So when we think of extreme events, again, most people here probably, have a feel for if you move the average, then you'll get a few more extreme events. Let's say it's heat waves, maybe fewer cold waves. But if the curve changes in some other ways, well, maybe extremes on both sides are increasing. So that's one reason to look at this. And of course, there's also very strong interest whenever, as Dr. Cicerone mentioned, whenever there is an extreme event. Very frequently now, somebody asks, well, was this related to climate there? Another part that's kind of interesting about the extreme events is, in many ways, it kind of makes climate real. and it makes the future climate real. It brings the future into the present, if you will. My kind of saying that I've used for a lot in talks throughout the years is while we plan for climate, we live in weather. Climate sometimes still to this day can be a little bit abstract to people. Weather is real because we all live it there. Okay, so this is really just kind of a synopsis of what our committee was asked to do there. And you can just read this as well as I can here, but it's really looking at the science of attribution of specific extreme weather events. I think that's kind of important. We were looked not to either evaluate a particular event and says yes or no where the climate link was, nor were we asked to comment in general, is climate changing the weather? That was not our task either. But it was really to examine the science of attribution of extreme weather events to human-caused climate change and natural variability. And there were three parts of this. It was to assess where we are today, the current scientific understanding, how robust are we in that science today? And this is really a rapidly developing science, again, as was mentioned in the introduction here, only 10 or 15 years at the most. And then finally, the committee was asked to give some thoughts or some research priorities on the way ahead. The committee, we have four members here today. Dr. Shepard. It helped if you were named Shepard to get on this committee, I guess. Dr. Walsh, and you can see the names of the other committee members. And again, I really just want to thank this committee. Everybody worked amazingly hard, very effectively and efficiently and as a team, and that's really why we were able to do this in 6 months. I also do want to thank the outside reviewers as well. Their comments significantly strengthened our conclusions. The conclusions, of course, are our committees and our responsibility alone. Okay, so one of the reasons I think the Academy has me come down here from time to time is because I get to entertain people with Navy sayings. So one of the Navy sayings that we have is something called the bottom line up front. Because if you've ever briefed an admiral or a general, you'll find that while in general they're okay smart, mostly, we have the attention span collectively of gnats. So if you don't tell us really right away what's important, we tend to lose focus. So I want to make sure that we get these some of these top-level findings of our committee to you very quickly here, because then we'll talk, for the rest of the report, we'll talk about parts of these. So really this is kind of what's new, is the National Academies is saying that it is now possible to estimate influence of climate change on some types of specific extreme weather events, and in particular heat and cold events, drought and heavy precipitation. And it's kind of a continuum, and I'll show you that continuum here later on. But the ones of the highest confidence are the ones that you see listed on the screen. Equally important, our committee believes that asking the right questions the right way is very, very important, and I'll talk about that a little bit later. But the way you ask the questions, the way attribution questions are posed, very much influences how they are answered. So two things: we can now do attribution on some types of specific extreme weather events as related to climate, and asking the right question the right way. So here's just kind of, extreme events 101, and I think everybody kind of, understands this pretty well here, is that, a whole lot of things have to line up to create an extreme event. And you sort of think about that, that makes sense, right? If you didn't, probably that event would be common, and if it was common, it probably wouldn't be extreme. So that all kind of makes sense. And there can be different causes, both natural and human caused as well. So all the way from large-scale circulations, different modes, or let's say teleconnections, all the way down to the specific weather pattern. On the human caused, climate change, what do I mean there? Anthropogenic greenhouse gases. But also the land use, whether that's agriculture, is it urban, do we have flood control, how have we modified? Have we modified large parts? We get urban heat islands, lots of different components. They all have to come together to create an extreme event. And here's just, maybe kind of an analogy here that would help for events. I wasn't able to find any cute kittens, because we all know that's really the way to go viral, but the next best thing may be cute cookies, because everybody likes cookies. So if you think of a cookie as an event, you know, a lot of things have to come together to get the right cookie, right? So, and you can read this as well as I can, but if you change any one of these, you kind of get a different event or a different type cookie. The other thing, if you think about it, is when you bite into that cookie that doesn't taste quite right, it's not always obvious why that happened. So you think of the attribution of what happened there, it can sometimes be a little bit more complex than you were thinking. Okay, we're not going to talk any more about cookies, but we found that sometimes just kind of something that everybody is familiar with sometimes helps here. So, attribution, I've used that word a number of times. What is it that I really mean? And really, it's the evaluation of these relative contributions of these different factors that cause a change or an event. And when we talk about the extreme event attribution, we're talking about how much did that individual event was affected by its magnitude or the probability, the frequency of occurrence there. Okay, so why look at these? And you know, there's certainly, I think, and I believe the committee, we talk about this in the report, so the committee believes that there are very good scientific reasons to look at this, and there are equally compelling social reasons. So on the science part here, this really gets into our understanding of some pretty deep details on how does climate and climate change start to impact down to the individual events, and can you say that, and where can you say that, and how does that work? And especially if you think of, I'm sure some people here are very familiar with tropical cyclones, you know, you may have some counteracting things. We have warmer sea surface temperatures, but we have some studies, not all, saying the frequency may be coming down. So you end up oftentimes, not always, but with these counteracting factors. How is all of that going to play out? And those are very valid and very relevant science questions today, so that we have an even better understanding going forward of this very complex Earth system here in the weather-climate interface. The social reasons are, if you think about this, as we talk about these changes in frequency and understanding this and changes in intensity or magnitude, those are really the two components of risk, right? Risk at its very simplest is frequency times an impact or a magnitude of an event. So if we can help people understand how those risks are changing and why those risks are changing, that is a very powerful tool in a toolbox of, be it a city planner, be it a CEO or chief operating officer of a Fortune 100 company looking to site a new factory, for an emergency manager understanding what kind of risk maybe population in a certain area has. So we think there's both scientific reasons and also very compelling social reasons to undertake this type of attribution work. So I'm just going to go through quickly here a couple of different approaches, and if you really are interested in the details of this, these figures both come out of our report, and you can read the details here. So my mission right now is not to go through the very guts of everything that are on these graphs, both on this slide and the next, but really just kind of show you how some recent attribution studies have used either observations or used modeling, basically computer models, in interesting ways to try to tease out the attributions. So one way, as this slide states, is with the observational record, and that picture on the left, if you can see it, is actually snow in Barcelona in 2010. So kind of an unusual event for anyone who's been to that part of Spain on the Mediterranean. It does not snow very often. So there was some work done here, and you can see the reference down at the very bottom by Cateau and colleagues back in 2010 to take a look at this. And they basically looked at when it was colder. They conditioned this based on really the negative North Atlantic oscillation, basically in cold outbreaks in Europe. And you can see the blue dots there in 2010. But if you look at the historical, we've had a long period of records, well over 100 years. Every 15 to 30 years, we get these cold outbreaks. The historical record shows that for that given situation, it was actually usually colder than what we observed in 2010. And you can see the difference on that third one. You actually see these kind of warmish colors there, and the graph really shows the same thing. So again, this is really kind of an interesting and useful way to use a long-term observation record, condition it with the type of weather, the type of synoptic situation, and come up with some interesting results. Similarly, Many of you may know that there was some very significant flooding in northern England in the year 2000. So again, Polly et al., different group of researchers in 2011 used a different way to look at this. And what they took was actually 4 different global climate models. But what they tried to do, their method was to really back out the human influence. And specifically, they tried to remove the influence of of the global warming on, or the human-caused global warming on sea surface temperatures, sea ice, and greenhouse gases. So what is run here is that solid blue line on each of those 4 graphs basically shows what the model was with today's climate for basically precipitation and runoff in this case. And basically the return period keeps going up, so higher return periods on the right. And then all those colored sort of different lines, there are many runs or ensembles of 4 different independent climate models run in basically the environment of what it would have been like in 1900, minus the greenhouse gases of the 20th century. And you can see that on some of the models, it was quite a bit lower, like on the purple one, the one on the top right. But other models like C and D, so the bottom left and the bottom right, today is close. It's at the very top, but it's close. So one of the things our committee found was that using multiple models helps increase confidence of exactly how confident can you be of a specific event, in fact, exceeding being different from what we had historically observed. So again, not to get into all the details here, but these are 2 different types of approaches, observational and modeling there. Okay. Some events are frankly and simply more attributable than others. And if you can kind of think of these 3 sub-bullets here, the 3 bullets, I've described this to a couple of people here yesterday as almost like a 3-legged stool. So attribution, kind of in highly confident attribution, rests on, do we understand the science? Do we understand the physics? Do we have long-term consistent observational record? And then finally, can our climate models today actually accurately replicate that event? And those are really the questions that you would want to ask when evaluating the science there. And as we kind of talked about in that bottom line that I showed you just a few slides ago, we say that we are in fact highest for the heat, extreme heat and cold events, hydrologic drought and heavy precipitation, medium confidence there. Now we have what we say little or no confidence in the attribution of severe convective storms. What do I mean by that? I mean like thunderstorm complexes that create like tornadoes and hail, extratropical cyclones, fancy weather term for saying low pressure system, right? Okay, we all know what low pressure systems are. So why do we say little or no confidence there? Does that mean that we're saying climate is not impacting that? That is not what we're saying. That's not what we're saying. What we are saying is attributing a specific, let's say, thunderstorm complex or a specific low pressure system to climate change. That is where we're saying there's little or no confidence in that, okay? And I hope that point makes sense, and happy to take any questions on that, but that's an important subtlety in this. Okay. All right, so if we take all those words, I like pictures, I'll bet a number of people like pictures. What we tried to do is kind of in one graph, could we sort of summarize what we have? And I think if you're looking for, so what's new about this Academy report, this is kind of new. We are not aware of any research that has really tried to integrate across multiple different types of extreme events, make an assessment of our ability to attribute those specific events. So again, you can see very consistent with what I've talked about, the heat and cold are the highest, and all the way down to the black is that severe convective systems, or basically thunderstorms with potential for hail and tornado and high winds. Now let me just mention just a second or two on what is it that we're showing here. So on the horizontal, or the x-axis, what we're showing is how well do we understand the impact of climate change, again, on an event type and really getting into the specific events. So we understand heat. I mean, you can go back to Fourier and Arnhus and those guys. I mean, we have long-term physical understanding of why it's getting hotter in the lower troposphere. On the vertical axis, or the y-axis, here's what is our capabilities, our confidence in the capabilities of attribution of those extreme events with respect to climate change. So here, remember my three-legged stool, this is really talking about our observations and/or modeling. And when I talk about modeling, by and large, I'm talking about the global climate models that roughly run at, let's say, 100 kilometers or about 60 nautical mile resolution. It's that order. So we're not talking yet about very high-scale resolution. So observations, computing capacity, and computing models on the left, basic understanding on the vertical axis, and basic understanding on the horizontal axis. Now you can kind of see that dashed line there, and it kind of makes sense, at least we believe it makes sense that we really don't have better capabilities to attribute if we don't understand. So if there are any economists in the room here or watching on the web, you can think of this as the efficient frontier, right? So in your investments, you want to be as close to the efficient frontier as you can, right? Maximize your return for a given amount of risk. Well, we want to maximize our capabilities for a given amount of understanding. So one of the other things that come out in this chart here is you can see lots of opportunities. There's opportunities on the science side. If we can increase understanding, we can move those bubbles further to the right. And if we increase either innovative ways to use and/or collect observations, better modeling and computation capacities, we have the potential to move up. So you can kind of see where we're already pretty good, still some room for improvement, and types of events where, frankly, we have a lot of room for improvement. And that kind of puts it all together in one chart. Okay, in the interest of time, I'm not going to talk a lot about this chart here. No, it did not come from Consumer Reports, even though it might look it for those of you who look at those. But again, if you sort of go back to my previous slide, and somebody may say, well, why are those bullets where they are? Here is the committee's assessment of those, again, those each legs of that stool, capabilities, obs, and the physics, and where we are. And you can see that for heat and cold, the committee assessed that we have high confidence in each one of those three, and so on down the line. Okay, so here's kind of the second part that is, I think, just as important as what we have talked about there, and this is asking the right questions. And I'll bet just about everybody in this room and probably everybody on the web has at some point been asked, pick an event caused by climate change? And people want yes or no answers, sort of like the McLaughlin group, for those of you who remember that. The committee assessed that that's really not a very well-posed question. There's always natural variability. We've talked about all these factors that have to line up. But some much better questions, and questions that we hope as a committee that are asked, in fact, more frequently, and not so much on the left, but more on the right, is are the severities changing? Is the intensity or the magnitude changing because of climate change? Are the frequencies changing? To what extent are the frequencies of these types of storms changing? And that's what we think are frankly better questions there. So interpreting these event attribution studies, I'll show you on an example here on the next slide that they're very sensitive to the way, again, you ask the question. And the committee did not come out with, this, you should ask them in a certain way, because different people have different needs. And there are certainly very valid reasons to ask questions in different ways. But you can get quite different answers out of the same data set depending on how you pose that question. So here's just an example. And this comes out of the Russian heat wave there back in 2010. And Otto and colleagues did this study actually in 2012. So the green dots, if you can see, are basically what the probabilities of a given summer in Russia, given summer temperature in Russia would have been in the 1960s. Those are the green dots. To the right of that curve, the blue dots are just the same thing, but in the year 2000s. So if you look at that, I'm going to see if this works here. Not really. The black vertical arrow that's pointing down, if you ask the question, what was the chance of having as hot a summer as was experienced in the year 2010, just under 25 degrees Celsius average temperature? That's actually pretty warm for an average temperature over a season. In the 1960s, that was about a 1 in a 100-year event. In the year 2000s, it's now becoming what I call a 1 in a mortgage event, roughly 1 in 30 to 35 years. That's a big difference. But if you ask the question, well, for a 1 in 30 to 35 year event, what's the change in the temperature? It goes from about 23 degrees Celsius to 25 degrees Celsius. And that, some people may say, oh, 2 degrees, okay. 2 degrees is actually kind of a lot on Celsius, but for a whole season, but sometimes that may not sound as big a deal. So when you change the, going from 23 to 25, that's the same data set as going from 1 in 100 years to 1 in 30. So again, how you ask the question matters. Okay, how we present these attribution results, we believe matters as well. And this is kind of the truth in advertising slide. We think that the studies are less likely to be misinterpreted when the choices and assumptions, and there's always assumptions and there's always choices, are clearly stated and the uncertainties are also carefully estimated. And the uncertainties are really, really pretty important there. And this gets all the way down into the statements of confidence and what are the impacts of the assumptions that we made. And again, this is a new field. People are experimenting. They're learning as we go right now. So we just think as our committee that it's probably getting about time to start thinking about how would we maybe put out some community standards for these. Okay. One other part I'll just briefly mention here is something called selection bias. Again, it's totally understandable that, especially for a new science, that as we do this, we tend to study things that have either high media interest, we were personally affected by them, our neighbors, our friends, our allied countries were affected by them. That might not be a representative sample, though. And where does that matter? If you don't have a representative sample, the committee believes that we should be very, very cautious about drawing general conclusions about the impact of climate change on events as a whole from a non-representative sample. That's kind of where that matters there. Okay, so as we kind of look through the attribution capabilities there, we kind of mentioned this once already. Transparent community standards we think would be very, very, okay, so we're almost done. We're getting close. Transparent and community standards would be very, very useful. How do we look at systematic criteria to minimize that selection bias there? So here's some ideas for research to improve event attribution capabilities. The first, the second, and the fifth bullets there, better models, better observations. You would probably be surprised if we didn't have that in here. But let me just talk for just a second about the third and the fourth bullets. And certainly some other fields, in physics, and Dr. Walsh can talk about this in a Q&A. Really work hard on uncertainties. And we think that the uncertainties are really quite important on understanding the event attribution. And also this so-called conditioning, this idea of conditioning of study results. So this means that for a given sea surface temperature, how likely was a certain amount of rain? Or given that the hurricane made landfall just east of New Orleans, what was the likelihood of flooding, let's say in Mississippi or Louisiana? Those are the kind of conditioning things that we're talking about there. And ultimately, can we, again, this sort of gets back to one of my very early comments about sort of pulling climate into the present, pulling that future into the present. Can we actually start at some point predicting sort of a basket, if you will, of extreme events, so lead times anywhere from days to seasons? And you could run these and you could verify these, because if we can predict them and we verify and we show skill at them, it's pretty then hard to argue that these things aren't happening or they're not caused by climate, or they're not caused by climate change, but climate change hasn't influenced those specific events because the computer models we would be using, in fact, incorporate today's climate. So we think that this would be very useful. We also think it would be useful for managing risk. because as those frequencies and magnitudes change and people can see we have skill at this, that tends to kind of make it real, if you will, when people have to put their real money or resources on adaptation measures there. Okay, and I think that is about it. Again, I just want to thank everybody, the NAS staff, my committee member colleagues there, for really a tremendous effort. You can see all the ways that you can have the report. Just go to the website. If you're tweeting about this, we even have a hashtag just for you there. So without further ado, we'll take questions here, and thank you very much.
Thank you, Admiral Chitley. Yes, we'll start with some questions in the room, and we're going to take some questions from those watching online, too. If you could just queue up at the standing microphones here so we could hear you, and please identify yourself and your organization, starting with Seth.
Seth Bornstein, the Associated Press. Well, one for any of you and then one for Dr. Walsh. In terms of the universe of all the attribution studies that have gone on since 2004, and I guess it was Stott was the first, what general percentage of them would you say meet your three-legged stool criteria, are valid? If a rough percentage or just some kind of sense of how much is valid. And for Dr. Walsh, Alaska seems to get more than its share of extremes, especially this past winter. Should there be a focus on more attribution studies on extremes in the more vulnerable Arctic, and what do you think that would show us?
All right, well, I would just say, I think the thing is we have to recognize it's a new science, and so if you look at the very early studies, for example, we say you should use more than one model. The very early studies would use one model, but that's normal, absolutely normal in science. You start with one thing, but there early on were certainly some that tried to bring together models and observations. So I think if you look at the most recent studies more and more, but I think it's also fair, I can't give you a number off the top of my head, but I think it is fair to say that there still are a number of confusing studies, even on the California drought. You find lots of studies that appear to reach different opposing conclusions, but actually are probably just asking different questions.
To put it a little, maybe if you can't put a percentage, maybe borrow some language from the IPCC. More likely than not to be valid, extremely likely to be valid. Give us a sense. At least more than 50% of them are most of them valid? The vast majority of them valid? The vast majority not valid?
Okay, I think we don't have those data there, and I'm not going to go and just make that up. What we were asked to do was evaluate the science of attribution, and that's really what we have done. So we went through these, and I think what we saw was, and has been mentioned already several times, this is a very new and rapidly developing science. So people are learning as they go. And we want to really thank all the sponsors for this, because it's really an appropriate time for the academies to weigh in to say, okay, now we've kind of started to learn, and you learn by doing. It's now appropriate for maybe there to be some type of standards, some types of best practices to be put in. And I think what Dr. Shepard was mentioning is that we're seeing some of the newer studies, by and large, doing that. But it's important, as we've mentioned, to state the assumptions, to state the uncertainties, because that really has a bearing on answering the question. As I tried to show with the Russian heat wave, you can get oh, wow, that's a big deal, or that's not a big deal, from the exact same data set, depending on how you ask the question. So we are not here to grade people's work. That is not our intention or our purpose, and we're not doing that. Our purpose is really to lay out a way ahead after assessing where we are. And the fact is that we can, in fact, do these attributions for some classes of specific events now. and that's what we're saying.
Yeah,
Marshall, do you got
yeah, I would just add to that because I agree with this notion that we're not grading. But Seth, I think one of the key points is the fact that 12 years out, I mean, you yourself mentioned 2004. I mean, we talk about dog years. In science years, attribution studies are babies. So in 12 years out, we are now confidently able to say that for a certain class of events, there is some moderate to high confidence in attribution. That suggests that though it was a wild west of attribution approaches, there is enough skill, fidelity, and knowledge for us to move the science forward in this now overdue assessment that the National Academies, which is in my view, and I'm speaking not as a pitchman for the National Academies, just someone that knows that the National Academies brings objectivity, it brings a gold standard to the assessment of science. It was time, and so I think there was enough good work for us to do that. So.
Yeah, I think one thing Alaska has going for it in this context is that it is in the Arctic, and with polar amplification, the signal we're seeing, the greenhouse signal we're seeing, is larger. I mean, Alaska has warmed about twice as much as mid-latitudes over the last 50 or 60 years. So in that sense, it's a nice test bed for some of these attribution approaches that we've heard about today. And extremes do seem to be increasing. One example I can mention is that the question has come up as to whether variability is increasing or not. And that ties in with the distributions that Dave Titley showed right at the start. So far, the analysis of the high latitude data shows that there's no smoking gun for increased variability, which means that most of the changes in extremes that we are seeing in magnitude and frequency are due to shifts of the distribution, not changes in shape of the distribution. So that's an example of the type of study that's ripe for work in the higher latitudes, because the climate change signal seems to be happening quicker up there.
Yes, sir, on the other side of the room there.
Steve Tracton, I'm representing, or at least here for the Capital Weather Game. I'm also here representing myself as a curious individual, just like to keep up with what's going on. First, a general question. You chose to look at extreme weather events as opposed to high impact events. And of course, the two are not necessarily the same. You can have a high impact event, which is not necessarily an extreme weather event. I'm wondering if that would have changed how you assessed the question of attribution.
Thanks, Steve. Just very quickly, yeah, we looked at extreme weather events because that's what our statement of task told us to do. That was what the sponsors wanted. I think when you start looking at high impact events, if anything, it gets harder, because impacts almost always have to do something with human beings and society. So now you get into addition trying to figure out that weather-climate interaction, which we have just gone through a whole report to say is non-trivial to figure out for specific events. Now you add in the further complications, if you will, of specific human, whether it's coastal defenses, whether it's flood protection, whether it's building codes. So even moderate weather events on an unprepared location can have a very high impact, and vice versa. Typhoons out in Guam, fine, you get 140 knots, they sweep off the streets, and the next day you're back to business, sort of like Okinawa. So yeah, there is not a direct correlation between weather and the impact. We were asked to look at the weather events.
I would follow up on that, Steve. Good to see you, by the way. That, as you know, a flood event. We had a flood event in Atlanta in 2009. Some call it a 500 to 1,000 year event. But part of the reason that event was so impactful is not necessarily just because of what fell out of the sky, but because of the urbanizations and some of these other factors that Dave kind of talked about. So same thing with Sandy. We didn't focus on specific storms in this. That wasn't our task, but some of the impact of Sandy was not necessarily meteorological at all. There were ocean processes, sea level, and those types of things, surge. I think it would change the results. I think it's perhaps something that's needed, but I think it further illustrates the compounded effect of the anthropogenic signal. One of the things that we alluded to throughout this report is that there are aspects of anthropogenic climate change that affect people, affect lives that aren't just linked to greenhouse gases. I mean, we know, for example, the 1995 heat wave in Chicago was much about the urban heat island. Humans build concrete and asphalt, so that's human climate change, but it was not related to so much to greenhouse gases. Now, as we're showing in this report, because we now have some confidence that heat events have a linkage to anthropogenic climate change, now think about this. The majority of people now live in cities. For the first time in history, we are an urbanized society. More than half of the population lives in cities. So let's kind of step back and say, oh, so the background climate is warming and increasing heat events. Couple that with the urban heat island, and so now you have a heat issue, heat mortality challenges that stakeholders, public health officials need to address. So this is why these types of studies are important. And oh, by the way, for those listening out there in the webinar land and on Twitter, scientists understand that we have an urban heat island. We don't use data from cities that are biased by the urban heat island. We got degrees in this. We understand it. So you often hear that when we hear the skeptic conversations about, oh, it's biased by the heat island signal and all that kind of thing. So I just wanted to make sure I got that.
I noticed when you said, Marshall, when you mentioned Sandy, the report, as I understand it, did not consider the effects of sea level rise on Sandy and in general. And one question, which I think more lay people than not are probably asking themselves, it's clear how folks can attribute global warming to heat waves, but you also include cold waves. How do you wish to explain that in the context of your attribution studies?
Yeah. So if you go, Steve, to the report and actually look at the
I haven't
figure.
read the whole thing yet.
I know,
Yeah.
that's fine. So I'm saying the answer is in there. So if you look at that report, many times, and Dr. Walsh also talked about this, some of the very recent work he's seen in Alaska, when we say cold events, it's really the lack of cold events. Or for a given synoptic situation, we're not as cold as we thought. And, you know, we could either write words and words of that, or that XKCD cartoon from about 2 years ago, I think kind of summarizes it just about perfectly.
Right, so folks have to understand that cold waves are in fact less cold as opposed
And
because
that's what
of
the report talks
warming,
about.
actually.
Thanks.
Could I just add one other example to Steve's question about impacts versus the actual weather and climate? The committee looked at this Northeast Snowstorm Index, which is relevant to this area, and we discussed it as a metric at one point. But that index is based partly on the population that's affected by heavy snowstorms. So it is an impact-oriented index, and we decided not to include that in any significant way in our discussion. But the trend in that index is actually quite a bit larger than the trend in the actual snowfall amounts, or the number of just heavy snowstorms that are not targeted at a particular area. So you have a good point that there's a distinction between impacts and the actual weather and climate variability that we're dealing with here.
Yes, sir.
My name is Martin Hurling, and I'm a research scientist at NOAA. I want to congratulate the committee for pulling together a very difficult report, but a very timely one. And knowing some of the people on the panel that had to assemble this report, the expertise is really quite stunning. The definition of attribution that the group gives actually is very nice, clear language statement, basically to identify the factors contributing to an event. My own view on that is that is a very rich and long science. It's not a new baby at all. Many of those that went into meteorology were very much engaged by extreme events that occurred, whether this was the 1976-77 extreme winter in the eastern U.S., whether it was a blocking summer in the UK, whether it was Galveston 1906. These are the types of events that affect society and have always been the target of meteorologists' desire to understand, so to better anticipate these events. So in that sense, what I see is a very refreshing, broad embrace of studying these types of extremes, not necessarily with any particular views to the factors responsible for better anticipating them. So I think that's a shout out I just wanted to say. With that in mind, the comment that I wanted to make had to do with this issue of asking the right question. As a scientist, questions are asked, almost all questions are right, if there's a scientific method that underpins the verifiability of the conclusions, the hypothesis that's being tested, and whether that testing of hypothesis leads to a prediction. So at the end of the day, really the goal is to make better predictions, to better anticipate these types of events. And in the context of today versus, let's say, 30 years ago, what has changed is really the factors, not so much the methods, although the tools have gotten better, and I appreciate the Academy
Could
calling
you,
that
in
out.
the interest of time, could you ask the question, please?
Yeah, so the
Thanks.
question is, what has actually changed in the ability to do event attribution in the way that we were doing it in the field 10 or 20 years ago? Is it the factors involved, or is it the methods that are improving, and where do you see that going 10 to 20 years from now?
Well, I think I would just say the first thing is the anthropogenic climate change part. So it's true that the statement of task talked about anthropogenic climate change and natural variability. But of course, as you said, there's a huge literature on just attribute to factors of natural variability. And actually, in a way, to have taken that on would have just caused our task to explode, and there already is a lot of other work. So we interpreted the way it's phrased in the title, actually, attribution in the context of climate change. And although we talk about the multiple factors and the importance of multiple factors, I would say that the novelty aspect is trying to pull out the anthropogenic part, but in the context of everything else.
I understand we have some questions from the web. Nancy, if you want. You can ask them here, sure.
Okay. Hi, I'm Nancy Huddleston. I'm a communications officer here. A number of you listening on the webcast have asked about the slides, and they will be posted at americasclimatechoices.org later today, so you can find them there. The first question from the web, what was the impetus for doing this report?
Well, we had sponsors who thought this was a very appropriate question to be asking at this time, and I think we tried to go through in the brief that this is a relatively new branch of climate science, attributing specific extreme weather events to climate. And I think there was a coalition between government agencies, and I just want to thank NASA, Department of Energy, and NOAA, along with several foundations who were kind of came together as a coalition of the willing, or whatever you would like to call that, along with the National Academies itself, was also a co-sponsor. And I think together they saw that it was appropriate time to do this report. So we did.
And, I would just add to that, it was time. I mean, every event, you got the question, was that caused by climate change? And what I see as a scientist and a stakeholder that's in the midst of this discussion, often in many formats, is that question was being abused by both sides of the ledger. It was being abused by those that sort of subscribe to the consensus science and the peer-reviewed literature. It was being abused by some that say, see, they're blaming everyone for every extreme event on climate change, so we can't believe anything. So we needed an assessment, and it was time. I agree completely with Marty that certainly the people have been studying extreme weather within the context of climate for some time, but sort of the corralling of this into sort of a body of literature in the scientific literature is a relatively sort of new concept from a discipline standpoint. And in my view, it was a wild, wild west, if you will. And this report now provides some degree of sort of, and I think you're right, Marty, I was blown away by the expertise, not only on the committee, but who we actually got to present results to us as well. So it's the best, I would say somewhat definitively, and I hope I'm not wrong on this, I think this is the best assessment that we have right now at this point in time on extreme weather attribution to climate change. It's right. It's a baseline. That's a good point, Steve. It is.
Okay, another question. How do we pragmatically take the wisdom from the attribution information and integrate it into managing probability of extreme events impacting transportation systems? And I guess you could say other things.
Yeah, I'll just very quickly answer that. The committee was not charged with that. So this is not part of the committee. This is just, kind of how do you do this? And, part of this is this whole idea of how do you get from data to decisions. But really, this is for risk management. And what I've just found in my personal work in climate is whether it's private sector or government sectors who are responsible for complex systems, complex operations, they're usually pretty good at working in a risk framework, because that's kind of how they manage lots of other risks to their business or their enterprise. So how do we feed in to that framework, understanding that climate is another risk that needs to be managed? It's not just, well, weather happens, because that's unmanaged risk. But you need to manage the risk, and you need to do that. You do need to understand these frequencies and magnitudes of extreme events. So we'll just leave it at that, but that's a whole other topic, but basically it's risk management.
Showstack, reporter with EOS at the American Geophysical Union. Thanks very much for doing this presentation. I wanted to push you just a little bit more, if I could, for you to clarify more specifically what is new here in this report, given all of the cautions noted in the report about attribution of extreme events. And secondly, I'd like to ask, what should the public, what should decision makers, what should scientists do with this report?
I guess, okay, the first question, well, I guess I'm not quite sure of the context of your question. So in terms of the attribution of single events, the novelty is the anthropogenic climate change. And then with regard to anthropogenic climate change, the novelty is the single events. For example, there's been a lot of assessments. The IPCC did a major assessment in 2012 on extremes. I guess there's probably been national studies here too, and so on. But those are always looking at statistics of extremes. Are we getting more heavy precipitation events? So the idea of trying to say what was a specific quantitative contribution to a particular event, that's a different question, because that particular event is occurring in a very specific context, maybe enhanced by a circulation anomaly or something like that. So then that's a very different kind of question than the question that the IPCC is trying to look at for statistics as a whole. So it's the intersection of the anthropogenic climate change and the weather event that is the novelty, I would say.
I would add to that. I think Steve actually did capture this. It's a baseline. Right? There were lots of different. This is a baseline. That's new. Secondly, if you read a headline that I just saw on Twitter from a major press release, I think that headline sort of captures some aspects of the novelty as well. I mean, it's one of the first times that we can say with some degree of confidence that we have high confidence in the ability to attribute certain events. I mean, that's been done for certain cases, but this is sort of assessing that there's high confidence in our skill level for heat and lack of cold events. That's new. John often talks about, John may want to build on this ranking, baseline ranking of, there have been sort of hedging thoughts on this, but this baseline ranking of our confidence in different classes of events, that's new. This caution about how the question is asked, coming from an informative, objective body on sort of, my goal, hopefully, is that we can essentially sort of lay to rest, put the tombstone on it, this notion of the question, is it caused by climate change? I think there's guidance on that that's new. One of the things that I think is very important from this report is this call for community standards on how to carry out attribution studies. I mean, that's new. So I would say that those things are very new.
Could I just add one amplification there? In a sense, we're pointing to stakeholders here and saying where you can get the most use out of the science as it stands today. With that ranking that Marshall mentioned, we're saying that questions about attribution can legitimately be asked about certain types of events, the ones at the top of the list. They should not be asked at this point in time about the ones at the bottom of the list. So I think we're showing stakeholders what the utility of the science is for them as of today, and I think that's a new element here that's come through.
So I'll just take the second part, and I'll try to be very brief because I know we're out of time and we've got people who still would like to ask questions. a senior policymaker asked me basically your part two just yesterday, and this is what I told that person. If you have convening authority, think of how you would use your convening authority, and I would recommend this be done not only at a national but an international level, because Europe is doing a lot of this stuff too. In fact, I would argue they're maybe ahead of us in some ways, to set standards. And that is actually something that can be done without a budget line. You could have a community to set standards. If I was in the government, I would do a crosscut and look at the existing programs and figure out where we might already have programs funded today that could in fact be helpful for predictive type capabilities. And finally, could we, whoever's controlling the slides, can you go one more slide? I forgot to hit the button.
Oh, can you go back?
There you go, perfect. So if you look at there, look at our graph on the lower left, another thing that could be done is you could say, it's not acceptable that tropical cyclones are that far down. By pick a number, 25, I want to see that bubble about where we are for heat right now. What is the research program? What are the capabilities that are required to get there? You can then set out all the way from research and development to operations, a program of record. I'm inside the Beltway, I can talk about this stuff here. And yeah, I go to the middle of the country, it's like, what are you talking about? A program of record that then could be measured to achieve that objective. So does that get into a strategic plan of somebody who's doing this? So the committee was not charged with saying where this would be in the pantheon of priorities, but if somebody wanted to, that is how you could use that. And then for an operator, understanding that some frequencies and magnitudes of predictive risk may be coming down the road, and start thinking about how you're going to use them in your business. Okay, we'll stop there because I know there's many
Yeah,
others.
I think we have time for one more
Okay.
question, sir.
Michael Swoboda with the Yale Climate Connections. I think a follow-up on that question, the American Meteorological Society has released a couple of reports on extreme weather events. Are those just data points in your work? Are you correcting work they've done? I'm just curious how those reports fit with that one, with this one.
Maybe the past president of AMS should probably answer that one. Yeah, I think you're spot on. I think those are data points. I mean, those are a collection of studies on individual events. And so we certainly mined those reports. We had people that presented studies in those AMS compendiums to speak with us as a part of our effort. So that activity went into our overall assessment of the science. Those are essentially, I've got a room full of individuals here right now. A certain number have on blue blazers, so those are individual studies, and then we kind of collectively take that information and understand what the fashion style of the National Academy is. That's what we do. I mean, it's kind of a collective assessment. That's what we did. So I think that's one of the things that interestingly in talking to some very smart reporters and press that I interact with all the time, I could hear that sort of underlying current of what's new about this because they're aware of these AMS type things. But this is very different. If you really step back and kind of listen to what we've said today and then look at what those reports are, it's actually a very, very different operation. So. One last thing I want to say, since that was the last question. This notion of predictive capability that Dave just alluded to, I think one of the sort of underlying currents that should come out of this report also, based on this notion of predictive capability that we perhaps see down the line, we sort of have this notion in this country that it's weather versus climate in terms of research. But as the Europeans have known for some time, if you look at their model, it's a continuum. And so this notion of establishing funding profiles, bills, et cetera, that are weather versus climate, I think one of the real sort of hidden lessons from this report is that we have to think about extreme weather and climate in this continuum, or else, you're not framing it right.
So we talk actually at the institution where I work at Penn State, we talk about our department is where weather and climate meet. And that's what we're doing. That's why my center is the Center for Solutions to Weather and Climate Risk, because we do see this as a continuum. And the extreme events are a way to bring that future climate into the present that we are all experiencing today. Thank you very much.
Yeah, and I understand there are more questions that have been asked by the online audience, and we will try to get back to you afterwards. So that will conclude our briefing. Thank you all for being here. I'd like to remind everybody that the full text of this report is available on our website, nationalacademies.org, and we'll try to get a recording of this session up online as soon as possible too. So I'd once again like to thank our committee for their service in being here today.
Thank you to the committee members out there online. I know there are a few committee members online too. I saw Phil Mote and a few others, Adam, so thanks to those colleagues.